The acid ionization reaction involves an acid in water to form the ionized acid and H3O+, where the acid, HA, has donated its proton to the water to become H3O+. These reactions have equilibrium constants designated by Ka. Notice that in the forward direction, HA is acting as an acid. And in the reverse direction, A- is accepting a proton from the H3O+, and so it is acting as a base. We designate these pairs of molecules, the form of the molecule with the proton and the form without the proton, as conjugate pairs. So the part of the conjugate pair that contains the proton is the conjugate acid, and the part of the pair that does not have the proton, so it will act as a base, is called the conjugate base. Every acid has a conjugate base, and every conjugate base has a conjugate acid. If we look at the base hydrolysis reaction, where we have a base added to water to form the base plus a proton and OH-, which is an equilibrium reaction called a base hydrolysis and has an equilibrium constant designated by Kb, we notice the same type of pairing. So we have a molecule that will accept a proton from the water. So it accepts a proton. It's acting as a base. And in the reverse direction, the molecule that has the proton, the base that has already accepted the proton, now has a proton that it can donate, in this case to OH-, and so it's acting as an acid. So again, we have a conjugate pair in this base hydrolysis reaction, and the same definitions apply. When the molecule has the proton, it's called the conjugate acid, and when the molecule has already donated its proton, it's called the conjugate base. Notice that when we put an acid into water, we form H3O+. And so an acid will increase the concentration of H3O+. When the H3O+ concentration increases, the pH will decrease. And so an acid will tend to decrease the pH of a solution. Conversely, when we put a base into water, it produces OH-. And so putting a base in water will increase the OH- concentration, and therefore the pOH will decrease. Note that when the pOH decreases, that means that the pH will increase. And so a base tends to increase the pH of a solution. If we look at the acid ionization reaction for a particular acid, and we then recognize that the conjugate base of that acid can act as a base, and so we look at the base hydrolysis equation for that conjugate base, we can write a base hydrolysis reaction with a Kb for that conjugate base. Now notice that if we add these two reactions together, that the HA is a reactant in one reaction and a product in the other reaction, so those concentrations will divide out. And the conjugate base is a product in one reaction and a reactant in the other one, so likewise those will cancel out, and we'll end up with 2H2O forming H3O plus and OH minus. This particular reaction is called the autoionization of water and has an equilibrium constant that is designated as Kw. Remember that when we add reactions, we can multiply their K values to find the equilibrium constant for the resulting reaction. And so we can write that Kw must be equal to Ka times Kb. Notice that this Ka and this Kb must be for a conjugate pair. So this must be the Ka for the conjugate acid, and this must be Kb for the pair, for the conjugate base of that conjugate acid. Just as we did for pH, we can designate the Ka and the Kb on a p, a minus log scale. And so if I take minus the log of both sides of this equation, I will see that I get minus the log of Ka minus the log of Kb is equal to minus the log of Kw. But minus the log of Ka can be denoted as pKa, and minus the log of Kb can be denoted as pKb. And minus the log of Kw, remember, is equal to 14. And so I can write that 14 is equal to pKa plus pKb. And so if I know the equilibrium constant for the acid ionization, I can always calculate the equilibrium constant for the base hydrolysis of its conjugate base. There is an interesting implication of these equations. That is, since Ka times Kb has to equal a constant, if I have a stronger acid, a larger Ka, its conjugate base must be a weaker base. And so we can say that as the acid strength increases, then the conjugate base strength decreases. So it becomes a weaker, the conjugate base is a weaker base when I have a stronger acid.